Okay, hello everyone. We're looking at level 1 geometric reasoning, and we'll just get through, and I'll do this in a few videos, but yeah, we'll just get underway. Okay, so this first question is asking for the length xw, so that's this length here, and so in relation to the angle, that's our adjacent side. This is our hypotenuse, so we'll be using cos. So I'll write out cos 42 equals xw over 7, then we'll need to multiply both sides by 7, and so that gives us xw equals 7 times cos 42, and we put that into our calculators, and that gives us 5.20 centimetres. Okay, for our next question, before we even read it or anything, I'm just going to notice that this is the same triangle that we had in our previous question. Okay, now it's asking us to find the length AC, so it's talking about this entire length across here, but it's worth remembering that we've already worked out that length. All we have to do is now work out that length. Okay, so in order to do that, I'm going to make use of this triangle, and I'm going to try and find this angle here. So we'll start by finding that angle, the green angle that I've marked there, and that's going to be 48 degrees, and that's by adding up our right angle here and our 42 degree angle there. And so subtracting that from 110, we get an angle of 62 degrees over here. Now in relation to that angle, this side is going to be opposite and this side is hypotenuse, so we can use sine. So I'm going to write that out. Sine angle equals opposite over hypotenuse, so sine 62 equals AX divided by 10, and then we can times both sides by 10, and that gives us AX being equal to 10 times sine 62. Put that into our calculator, and that gives us 8.83 centimetres. Now earlier I talked about how the side AX, so that length, plus the side CX, so that length there, is equal to the side AC, which is what we've been asked to look for. And so in other words, AC is going to be equal to 5.20 plus 8.83, and so that's going to be 14.03 centimetres to 2 decimal places. Okay, on to our next question. It's asking us to show that this angle is 42 degrees. So it's talking about this angle here, and so to do that I'll label these two sides opposite and adjacent, so we're going to be using tan. So we can say tan angle equals opposite over adjacent, and substituting in we have 9 over 10, and when we're looking for an angle we take the inverse, so we say it's tan inverse of 9 over 10, and we put that into our calculator, and it gives us 42 degrees, and that's it. Next question is asking us to show that use trigonometry to show that Pythagoras' rule works, and so if we're using trigonometry, I'm going to be wanting to find this length here, which is the hypotenuse, and it doesn't matter which of the other two lengths I use, I'll just use this one here, and so that's going to be adjacent because it's next to the angle, if that's the angle that we're using. So I'm going to use cos for this one, so I'll write that out. Cos angle equals adjacent over hypotenuse, and so we can put in the angle of 42 equals the adjacent side, which is 10, over the hypotenuse, which is the side FH, so I'll write that in, FH, and in this situation we want to say that FH is equal to 10 divided by cos 42, because FH is on the bottom there, and putting that into our calculator we get 13.45. Now let's try this with Pythagoras and see what happens. So I'm going to call this side A, B and C. So let's write out Pythagoras' theorem, and we get a squared plus b squared equals c squared, and so we're going to have 10 squared plus 9 squared equals c squared, So c squared equals 181. Taking the square root of both sides to get c by itself, and that also gives us 13.45. And so since these two are equal, we can say that Pythagoras works for this. So since both methods yield the same result, Pythagoras works for this triangle. For this triangle. And that's it for this